I'm doing competition math, and in this problem we are going to talk about operations T and S. They commute, by definition, if whenever you swap them around, right, the order of the operation does not really matter, right? So if you did S first and then T, you get the same thing as if you do T first and then S. So that's a commutative operation. Now consider the following four operations, all of them on the two-dimensional coordinate plane. You translate two to the right. That's one operation. Another is you do a 90-degree counterclockwise rotation about the origin. Another is that you reflect about the x-axis. And finally, we dilate by a factor of 2 at the origin. Which of the pairs of these, and we are considering distinct pairs, so there are 6 distinct pairs of operations here, of those, how many commute? Well, I don't think I know any better way than just like running straight through them, so let's just think about all ways that we could put translate together with the other operations. Let's start with rotation. Now, if you translate first, just pick an easy translation. I guess we have to go by 2, but shouldn't really matter. Anyway, we go to the right by 2, and then we rotate by 90 degrees. That puts you up along the y-axis. Now imagine doing it the other way around. You rotate the origin. Let's think about where the origin goes. It stays right where it is when you do the rotation. Then you shift it to the right by 2. Well, you're now along the x-axis 2 coordinates out, so that's not the same thing as what we got the first way of doing it, so that does not commute. Now, in the next one, we're going to do translate and reflect. So again, let's imagine taking the origin point, shifting it 2 out to the right, and then reflecting over the x-axis. Now, it's just going to, right when you reflect over the x-axis, it just stays right where it is. Now, think about doing it the other way around. You reflect so it stays right where it is. Then you shift to the right by 2. It goes to the same place. And if you think about it, if we had done this, that was just, picking an easy point like the origin. But if you picked any other point and you shift out to the right by 2, reflect, you'd get the same thing as if you first reflected and then shifted. So, we could work that out in a more sort of like, algebraic way, but we're trying to be fast. So I'm going to take that as a good argument. Okay, next let's try to translate and then dilate. So we go out to the right by 2. We dilate by a factor of 2. Now we're out along the x-axis by a factor of 4. Now, what if we did it the other way around? We are starting at the origin, we dilate by a factor of 2, so we stay right where we are. Then we shift out 2, so we land on 2, not the same place, and therefore not commutative. Now, the next one's relatively hard to think about because we're going to do a rotation and a reflection. Now, the rotation just leaves the origin point where it is, and then the reflection leaves the origin point where it is. So certainly the origin goes to the same place no matter which order you do it in, but we want to, that sounds like that could be deceptive. So let's think of a better point. So there may be other points you could pick to do this, possibly even more easily, but I am going to pick the point 1, 1 just with the kind of the confidence that if something goes wrong, I'm going to see it go wrong with 1, 1. Likely, not, that's not like a principle, but I'm just fairly confident in that in this particular case. So anyway, I pick the point coordinates 1, 1. I first rotate by 90 degrees, so that sends me over to -1, 1. Then I reflect, so I'm at -1, -1. Okay, now I'm going to do it in the other order. So I'm first going to take 1, 1 and reflect. I haven't drawn that, but you would get to 1, -1. And then you're going to rotate by 90 degrees, sending you back to 1, 1, which is not the same point as the last time, so these two do not commute. Now, this might be a little bit of cheating, but I think it's just intuitively obvious that rotating and dilating, because they're both these kind of like circular operations that are centered on the origin, it's not going to matter what order you do them in. You spin everything around and blow it up, or you blow it up and spin everything around. You'll get the same result. So these two do commute. And also on this last one, I am again going to argue that it's somewhat intuitive. It maybe takes a little bit more work this time to see it, but if you sort of flip something around and then dilate it out, you should get the same thing as if you dilated it out and then flipped it back around. So again, we could argue all of these things more rigorously algebraically, but if we're trying to move really fast, then I take that to be a convincing enough argument to say that this does commute, and now we've got 3 things, 1, 2, 3 things that commute.